Hi, my name is Sam Parnell and I chair the Ipswich and Suffolk Tech Network, and we are a group of meetups that work across all of Suffolk. There are about 15 meetups altogether, and within our ranks we're lucky enough to have a coding school and a makerspace and just multiple different groups, AWS user group, etc. So we are I think we're at SyncIpswich this evening. So SyncIpswich is tech startups plus innovation, and we are getting a talk from Paul Graham, who works with Matrix, who've spoken for us before. And the talk this evening is the book RAN. So Paul, I will pass over to you to introduce yourself and give your talk.
Thank you, Sam. Yeah, I'm Paul Graham. I'm Director of UK Engineering for Matrix Software. We're a US-based telecoms company specializing in the charging space, now very big in 5G. This talk is it's a follow-on from my previous one on cloud native and applications of 5G in that space. I decided to give this one as this is ORAN, which means Open Radio Access Networks. I'm not myself an expert on radio access networks for 5G or any mobile. However, part of this is to kind of demystify some of the terms flying around, things like virtualized RAN, new radio, and ORAN. How do these things fit in? It's more of a reference talk. It's a bit technical, and yeah, the good idea is to really watch it online, right? You can go back to it, flick through, and then some of the concepts that come up, you can then go and reference yourself and find them out about them, okay? I've broken a few rules in this speech. Some of the slides are a bit wordy because it needs some, more technical information. Don't usually do that, but for this one, I've made an exception. And yeah, we'll go through. So this is about the gender. Okay, so we've a few slides on 5G refresh, what 5G is about, why it's relevant here. History of mobile radio. We take mobile radio for granted. We have mobile phones. We don't really know how it works for the rest of everything else, right? But there's radio in there, very complex, very technical radio concepts. Then we move on to what 5G radio technology means. You hear about 5G all the time, but there's also some deeper stuff in 5G to do with the radio access network. We hear terms like virtualized RAN, open RAN. What is the difference? How does it apply to 5G? How does it apply to previous generations of mobile? And then one of the components of Open RAN is the RAN intelligent controller. And this is an opportunity, right? Because as I'll explain at the end, the government has recently put out some bid work to kind of get this going. We hear in the news about Huawei being pushed out of mobile, but that only leaves us with Ericsson's and Nokia. So the UK government is actively seeding in this space. So one of the things I'm hoping to do here is kind of generate some ideas. There's potential businesses, and actually here in Ipswich and Suffolk, the list of the winners of the initial tender process, there's a lot of them here, right? We don't understand that, but here at Ipswich and Industrial Park, there's a lot of players in this space or potential future big players. So that's why I've decided to highlight this and turn it into a talk. So use cases, yeah, and those opportunities. So the first one is going back to what 5G is about. Well, of course, I always say, of course, it's always about more bandwidth. Every generation of mobile is about more bandwidth, right? It's data to your phone. It went from sort of video clips to full videos, and now it's to do kind of augmented reality where you need high bandwidth, sending video to a server, getting the video back. Those kind of applications. Low latency, that means the speed the data travels through the network has to be very quick to be able to do those industrial applications, self-driving cars. Slicing, that's quality of service all the way through the network for the radio and the services as well. High device density, you hear the term IoT on 5G. Well, if you're going to have millions of devices on network, your radio has to be up to it. So spectral efficiency is the term there. Yeah, it's all based on now cloud native and web scale. So not just the applications going in the cloud, aspects of the radio access network going into cloud as well. Talk about that a bit later. And CNFs replacing VNFs. So containers replacing virtualization, right? Yeah, so it's more than just faster speeds. This is the classic triangle of applications for 5G. You've got enhanced mobile broadband, so places where you can't put fiber in, you can put antennas up and you can give the occupants of houses gigabit broadband to the house through the radio without having to put cables and fiber in. Low latency is about industrialized applications, self-driving cars, gaming, anything where between your handset or the device and the back-end systems has to be very quick. Augmented reality, those sort of things, right? And then massive IoT. And massive IoT, yeah, purely about spectral efficiency and the ability to put millions of devices on your network, which you can't do now. Go into any place where there's a high pop, lots of people, and you hit problems. Go into a stadium on a sports day with thousands of people there, the network's not up to it. So 5G is about these kind of things as well. Now, here's the reference slide. Now, in the first talk I gave, we talked about the things on the top, which is the control plane. So here at Matrix, we do charging applications. So we've got the charging, but we've also got the traditional components, which have been renamed. UDM, that used to be HLR, HSS, SMF was the packet gateway, SMSF, messaging. But now we're talking about the user plane, which is the bit down below. And that's the connectivity between your phone, which is the UE, user equipment, and the radio access network. So base stations, backhaul, and the way you connect back into the internet. So we're focusing on the bottom layer today. And maybe in the future, we can focus on the business apps and applications of 5G, B2B2X, as it's more fashionably known at the moment. So here's a brief history of base stations. Base stations were big monoliths. If you look at this picture on the right, I went out and found one. You've got the cell tower, you've got the radio head, which are the antennas on the top. You've got these cabinets full of proprietary equipment, doing baseband stuff, connecting backhaul, sending your data out, doing the encoding, the encryption, modulation, all those things is going on in this one big thing, right? Now, that's very inefficient. If you want to get maximum coverage of a population, you've either got to put thousands of these things out, or you've got to find a more efficient way of doing it. We don't have full coverage. We have very poor coverage because of the cost of putting radio out to cover the population. It's reliant on backhaul. Backhaul is where you connect the cell tower back to the main network, and that's a fiber proposition, right? I mean, it's no good putting a cell tower out in the middle of nowhere if you can't get to it. You need fiber to it, fiber backhaul, you need gigabit. So when we talk here about this fiber rollout nationally, actually 5G depends on that fiber rollout. If we're going to have antennas on every lamppost, they need to be connected with fiber. And also you require power, and powering base stations, that's quite difficult as well. So we need ways of reducing power, increasing backhaul, and putting it onto commodity hardware into the cloud to reduce the cost, so we can eventually have complete coverage across the population and the country. And that's what this is really all about. Bringing the cost down, improving the coverage. Evolution of mobile radio technology. I won't say 1G. 1G was analog. It's almost like a CB radio. But 2G was where it starts with digital. So we had frequency division, multiple access, and time division, multiple access. 3G was about spread spectrum, code division access. I believe that wasn't really considered a good idea. That's why they moved on to 4G, which is orthogonal frequency division, multiple access. That's a way of modulating your frequencies as you send out the radio. 5G is an evolution of that, and including the millimeter spectrum. And that's what we move on to now, the 5G aspects. Right, so 5G new radio. It's the new global standard for the air interface of 5G. That in itself isn't that remarkable. The remarkable thing probably is the increased frequency bands they're now using. So 400 megahertz to about 700. That was the existing spread. You've also, you've got those kind of Wi-Fi frequencies. You've got the unlicensed spectrum, which they're putting in there now, anybody can use. But now they're going up to the millimetric frequencies, the gigahertz frequency, that's 240, 24 gigahertz and beyond. What that means is you've got a lot more spectrum to use. It's higher frequencies, which is all about more devices, but more cells and microcells in terms of the overlap. It's designed so 5G will work with 4G. Previous generations don't really work together. You've got to assign bands of you've got to assign bands for each generation, but 4G and 5G will work together in dynamic spectrum sharing, which is another thing. So they will continue to work together while we switch off 2G, 3G to make more room for these newer technologies. Let me just go to the next one. Okay, so yeah, 5G radio technology at the moment is quite poor, right? You need to roll it out. I've got a 5G phone. I get it in the centre of Ipswich. If I go to London, still need to roll it out. Yeah, economies of RAN need to change if we're going to get this complete coverage. Right, so it's a cost-effective method of realizing this coverage, efficient use of infrastructure with spectral efficiency. And spectral efficiency is the schemes you use to utilize those bands in the spectrum. Complex, but the idea is you've only got so much spectrum. Everything is competing for it. Mobile, radio, TVs, and you want to efficiently use it. So virtualized RAN. So when we talk about virtualized RAN, RAN is radio access network. Virtualization, we think about putting in cloud computing, containerizations. Of course, radio does not go in the cloud. We don't have antennas in the cloud. The antennas are physical things which have to be out there on the cell towers, on the lampposts, whatever, right? So the idea is you take that monolithic base station and you split up into various components. And the first one you've got is the radio bit, the radio unit. That is physical. You cannot virtualize that. That's got to go out there. But some of the other components, like the baseband unit for the modulation and the control, that can go in the cloud and virtualization in the edge computing. So that's one of the things you do. And then you've got another aspect, which is how does it connect to the rest of the network, the backhaul? That's another component. So what you do, you break that monolithic base station that we saw with the tower and the cabinets, and you take the components and you can put them into the cloud. And that's what O-RAN is doing. It's about 5G specifies the net radio interfaces and how you use the radio and the protocols. Virtualized RAN is about putting it into the cloud. Open RAN is about chopping it all up and coming up with an open way of creating these separate components for your radio network. And that's where it opens up the opportunities, because you can cut them up and everybody else can develop a piece of their own components. It's not only about 5G, but I don't think people will go back and retrofit previous generations into virtualized RAN. They will focus on 5G and use that and take that forward. So here's the open RAN architecture. And okay, so we've got the UEs, which is the devices, the handsets, the self-driving cars, whatever else, industrial things, your watches. You've got the center pit, which is now broken up into several pieces. You've got the radio unit, RU, that's the physical device that's out there. You need to connect it with fiber back to the distributing unit and the central unit. And these are the things that control the radio network. You've got the RAN intelligent controller. And when you hear about AI and ML in 5G networks, and well, that's the bit that's going to do that for you. That's going to control the networks, bring in the usage information, and do the clever stuff, the steering, and control the networks so they're fully optimized. And these are then become opportunities of things that new companies or the new in the ecosystem can then create. Okay, I put a lot of words on here, but I thought it's important to have this slide because it describes those components. So you've got the Open RAN radio unit, for processing of the physical layer, which is the radio. You've got the distributed unit, which is what they call baseband, does the clever stuff, the modulation, encryption, all those sort of things. You've got the central unit, which is the bit that connects back into the network. And then you've got the intelligent controller, which is taking the information out of the network, applying your algorithms, maybe with AI and machine learning, and then controls your network to optimize it. And yeah, you can write applications on that, and that's an opportunity for somebody to develop businesses around efficient RAN controllers. This is how the stack looks. So at the bottom, you've got the physical aspects, the radio. It then connects back into the distributed unit, and you can have one distributed unit to many antennas. So that gets you efficiency. Rather than have a monolithic thing in cabinets, you can have one of these units serving many antennas. So if you've got a load of cells over lamp posts, they could be connected by fiber back to this kind of stack, which then makes 5G, as it's described, possible. You then get it then becomes economic to roll it out and get the coverage that you need. Yep. So a RAN intelligent controller is about optimizing and controlling the RAN architecture. Right, sits in the network, takes in all the information, and then sends out control to the distributed unit and the radio, how it controls the main network. And this is how another stack on the RAN intelligent controller. And you see you've got a real-time element, which is controlling the radio access network, your base stations and the radio, and connecting with the user equipment, determine how the user equipment connects back to cells. If you have a road of cells on lampposts, you only want to be talking to one, so that whole ecosystem has to be controlled. You have the offline bit, non-real time, and that's the AI components, which is doing the AI and the algorithms to put it back into the real-time components. So the classic use case is O-RAN traffic steering. So you've got your phone in here, your device. You've got because you're now going 5G. It's not just one massive cell site covering the whole of Ipswich. You've now got radio on every lamppost. As you're driving down the road, you've got to control how the phone and the cells connect to each other. So you've got to steer the traffic. And that's what the classic intelligent controller can do here. You then move on and you can have lots of handsets, lots of cells, and all this has to be controlled, right? At the moment, you've got one big cell, everybody's connected into one big cell. There's no issues there, but there is if you're in a stadium and you can't connect in, right? To get the large scale connectivity with many devices, you've got to have an intelligent device in the center controlling the cell towers, the radio access with all the devices and how they connect to each other. And that's what's new here. And that's how you get your efficiencies. Yeah, so it's a way of how you deal with your user equipment, you bring it all in, and how you prioritize your cell phones can connect to certain towers, and how all this is managed. And this is one of the big leaps in 5G, how you manage your radio network. It's no longer dumb anymore. When you switch your phone on, it connects into the nearest cell. Now your phone is going to work with the network to determine which cells and which radio access components it's going to use, and then how you steer the traffic towards it. So opportunities. The opportunities here are to develop those applications using AI and ML techniques. You'll hear a lot about private networks and neutral networks. Well, these are basically where we can go out, build our own network, doing something, and then we can connect it back we can sell capacity on our private network back to Vodafone. And what you might have heard about in the last few months is how Amazon AWS is now launching its private 5G network in the US. They're using the unlicensed spectrum. You go online, if you want to set one up, you order your cell, you connect it into the network, so you get effectively a radio unit. It goes over the internet, connects back to the components I showed you, and bingo, you've got your own 5G private network, just like that, according to the marketing. And you can see how eventually Amazon will basically have a countrywide deployment of their own radio components, and they will eventually have some kind of network by doing this. And I was only reading earlier, actually, Dish, one of our customers in the US, they're building a network based on O-RAN, and I think they're working with AWS as well. So that's one way of rolling out a new 5G network efficiently, because it's no longer a lorry load of equipment to put up a cell. You go to Amazon, it comes via your delivery man, you plug it in, connect it to your network, and bingo, you've got a 5G network, because those other components at the back end were described and have been offered in the cloud by Amazon. Yeah, lots of and the Port of Felixstowe down the road from us, that's the poster child of 5G networks. That's the classic use case. It's a complex port. Felixstowe is a technological marvel of what goes on there. It's not just lorries chucking containers on the ships. There's complexities in managing the containers, where they are, what's in each container, where it has to go, load on, load off, loads onto the ships, balances the ships, controlling the cranes, and it's those kind of applications and the economics behind it. You'll be able to set up your own private 5G network and use it for industrial control. And the key to that is Open RAN. So companies like AWS can now offer it very cheaply, because the radio head component it's small, it comes in the post. The back end stuff is in the Amazon clouds. And it's realizing on the O-RAN dream. Right, so I'll just cover another opportunity. The UK government is investing in RAN startups. You've all read it in the news about alternatives to Huawei. Want to get rid of Huawei at the networks. The problem is they were quite cheap. So you get rid of all this cheap stuff. What are you left with? You're left with Ericsson's and Nokia. The government wants to diversify the 5G supply chain. So put out this kind of process for companies and startups to get some money. It's only 30 million. You can't really do much with 30 million. But it gets the ecosystem and it's seeding things, right? And that's a start. So, anybody watching this that has some ideas, wants to build a RAN components, well, there's people out there investing. And some of those companies that won that money are actually based in industrial park. So it's all very relevant to this area. Yep. So if you're looking for something, an idea, or something to invest your money in, or a company to start up, maybe you want to consider RAN. Okay, RAN. So conclusions, coming to the end, right? We need to reduce the cost of radio deployment. We need to break up those monoliths. 5G is about it. We have open radio access networks. They're virtualized, so part of it can go in the cloud and reduce the costs, as AWS have been doing. Big opportunities for people to develop components of RAN and just get out there. You know, it's going to be huge business, no doubt about it. You're going to get deployments that they're talking about. Somebody has to supply all this equipment and services, and it's only just beginning, right? So if we're going to realize the dream of 5G, millions of devices on, somebody's going to have to build this. Okay, so that comes to the end. I know we've got a smaller audience. Are there any questions? Or I'll give you something to think about.
You've given me something to think about. I suppose the point of the Ipswich and Suffolk Tech Network is to support innovation in Suffolk specifically. And as I was at a talk last week given by Lisa Perkins about BT. Yeah, it's really nice because it tells the history. Is this going to come from Suffolk, I suppose, is my question. And is it only going to come from Suffolk? Is there is there more opportunities for collaboration? I mean,
absolutely. The point of RAN is where before, right, your Ericssons or Nokia, they were the only people that built these things, right? Now it's about letting smaller companies develop the software components. Now, we are very big in this, right? There's lots of things going on in this area. Lots of things at the park. Agritech is another big one that need 5G networks. If you're going to control your, industrial equipment, your farms, drilling, plowing, and it is going to be a Suffolk thing, or can be Suffolk, right? We don't know it yet, but there will be business in going out and deploying these private networks. So yeah, I think it's a big opportunity for here in Suffolk, actually. And
if somebody is interested in that kind of innovation, who leads on that project for Suffolk?
Yeah, well, maybe maybe at the moment there's nobody leading it, right? Say some of these companies are at the park, but I don't see any leadership in how do you consolidate or bring this stuff together and create more opportunities, right? People may not even know that opportunity is out there. It is out there. The government. The government did put out this proposal for people to bid for some money. It's the government. Maybe we need to bring the government here. There's a 5G supply chain aspect to the government department, the digital media department, right? And maybe we need to bring these people here and say, look, we've got the talent and skills, invest some money here.
Interesting. Richard, any other questions? John?
I was somewhat curious about the touted massive throughput of 5G, which I think you might have half explained by telling me that there were high frequencies involved, but I didn't get any feeling of how that compared with the frequency ranges used with the older tech.
Yeah, okay. I mean, the thing about mobile, spectrum, right, is that the higher frequency you go, the more throughput. However, the coverage reduces, right? So you need more cells to get that coverage. And there's a bit of a sweet spot, I think, at the sort of, 3 gigahertz.
The cost benefit analysis.
Yeah. The thing is, you've got to think out, if you get a gigahertz on your phone, that's probably enough, gigabits, that's probably enough, right?
I think it's more than enough for me.
It's more than enough, absolutely, right? So we're not really, as I say, people talk about higher bandwidth. Yeah, you get higher bandwidth, but that's not really what 5G is about, right? 5G is actually coverage, because no matter what you're told, if you go out there with your phone, the coverage is not that great, right? If you're going to rely on these apps to drive your cars, or you're going to walk around with headsets on or whatever to create augmented reality, you've got to have guaranteed bandwidth or coverage. And it's more about guaranteeing that coverage and improving the coverage. You know, if you want to use this for agritech and you want to plow your fields, you've got to have complete confidence and coverage in that technology. You know, I mean, down at Felixstowe, interestingly, the reason they went for 5G at Felixstowe, or in LTE as well, is because of the coverage. Wi-Fi doesn't really cut it with coverage, right? So this is more about coverage and latency. So you can use it for those other applications. It's not so much about bandwidth, because, you know, on your 4G phone, you'll get enough bandwidth to watch movies, right? Yeah, you're no issues there. But if you want to have those control applications and have it ubiquitous everywhere, then this is what this technology is about.
Okay, so is it solving the coverage problem, assuming we get the saturation bombing of masts that you just described in one of your slides? Because you said at one point there might be one mast in the middle of Ipswich, which I guess was
that was like the previous generation, right? You know, if
you had like lots and lots.
Yeah. If you, at the moment, you know, the 4G coverage is, there's not many masks, right? If you look at a coverage map, you don't need many base stations to cover an area on that basic stuff. But then when you move out of Ipswich and try going on a train to London, your coverage is appalling, right? You know, and that's what this is about.
Okay, but it will rely on people putting up masts essentially in places where there are a few cows and a sheep to be broadcast at, so that when my train goes by, I'll have coverage.
It's those sort of things. Yeah, that's right.
Okay, so the commercial imperative to do that seems to be weak.
Well, it's how you want to sell it, right? Yes. The commercials are probably not there at the moment. If you look on a coverage map of the UK, it's still quite poor, right? You know, so you're going out there. But so if you're selling a proposition to somebody, use a mobile phone and use all the data, how many other industries will get away with it not working in a lot of places when you sell something?
Well, I feel the same way about that as I do about my broadband. I don't really care about the guy next door. I want mine to work.
Yeah.
Which, of course, is a very selfish viewpoint.
Yeah.
But having lived in an area where we were lucky if we had 1 megabit per second for a long while, I'm going to be selfish for a little while longer.
Yeah, and that's why we haven't got the fibre or the broadband rollout, right? Because you cover most of the population, and there's places you can't get to because of the economics, right?
Yeah, and that's what I'm slightly wondering about, is that the economics sound like they will be in much the same direction, in that there will probably be places where nobody wants to go, in the sense of nobody wants to.
Yeah, but it also, the thing is, right, it also covers the situation you're talking about, where somebody wants broadband in the village out at Alford but can't get it. And I'm citing a proper example there, right, where this technology will help you. So it's not just about mobile, it's about ubiquitous coverage, full stop. You know, it's not just about somebody on a mobile, it's about hitting those places where coverage of any connectivity is poor at the moment.
Okay, thank you.
Thanks very much, Paul. Very interesting. And I'm going to plug something to, we haven't got a massive audience this evening, although it's odd because this is so relevant. And we spend such a lot of time talking about tech innovation. Without this infrastructure, these snazzy jazz hands and vibe things won't work. So, however, we have another network where innovation can live in Norfolk and Suffolk, which is the Norfolk and Suffolk Innovation Network, which is it's currently being deployed 220 LoRaWAN gateways across Norfolk and Suffolk. So again, for any it's not going to work when your train goes past, but if you do need to do something in a rural environment, LoRaWAN's obviously going to be a lot more useful for you. So the innovation race is a competition for innovators to scope out solutions using IoT to assist local government in solving their strategic aims. So we basically, through the month of June, we've got a series of events and everybody's welcome to either join. There'll be 8 teams. There's a prize of that £5,000 for the winning innovators. And we will have multiple events. So again, very much about bringing everybody together in a space to run workshops, have conversations about sharing. We're big believers at the ISTN that learning technology is not about learning a specific thing. It's about learning how to learn technology.
Yeah.
And so that's what it's about, coming together, networking, developing ideas, developing your professional skills. So we know that students are particularly interested in that. So if you are interested, get in touch with us at the istn.org.uk, or alternatively, you can look at the Innovation Network. I can't remember the specific URL. I think it's innovation.uk or innovation. If you Google the Norfolk and Suffolk Innovation Network, you will definitely find it. Right. And so there we go. Go and sign up. Come and try and win £5,000.
Yeah.
At the ISTN, we have lots of talks coming up. We have an incredible amount about telco. There's no doubt our history in this region is very much embedded in telco, as Paul said, and this is a relevant talk for us. So, and it is likely to be something that innovation that sticks around in this area. So we've got one about SD-WAN next week, and then there's multiple different talks about, I think we've got one next Thursday, which is about entrepreneurship and leadership. So if you go back to the istn.org.uk, look under our events, there are multiple events. You're all welcome to any of them. They're free to attend, open to all, and we record them, and you can see the recordings later. Anybody who has signed up to attend will get sent this link. If not, it will appear on the website as soon as it's been produced. So that's it. Thank you very much to Paul. Thank you to everybody who's attended this evening. If you've got any other questions for Paul, I'm sure he would be happy for you to get in touch with him. He's Paul Graham. You'll find him on LinkedIn of Matrix fame. Thank you all for coming. We'll see you soon.
Right.
Thank you so much.
Thank you, Dan. Catch you later.
Thank you very much.
Bye.
Bye.